All right, guys, we're graphing problem number 13 from your 3.3 practice packet. And what you see here is a piecewise function with 4 different chunks. So we are going to have 4 different pieces here, so let's get started. Let's look at this first piece right here that I'm going to be using orange. We have a domain of x is less than 3. So that's going to start here at -3, and it's going to be less than, so it's going to shoot to the left. We do have a linear function, so a y-intercept of 10 and a slope of 3. Y-intercept of 10 up here and a slope of 3. And I'm going to worry about erasing later. 1, 2, 3 here. Positive 3 means it's going to look something like that. So let's get that. All right, so we've got our line graphed here, and everything to the right of -3 is going to be erased because we're looking at just the points that are less than -3. And I am also going to just verify where my my boundary point should be. I'm going to plug that in. So 3 times -3 plus 10. So I get -9 plus 10. And so I should see my point at 1. So is this going to be an open circle, because I have that, on -3, positive 1. Okay, there we go for that piece. All right, so let's go to the second piece. We have -x squared plus 5, and it needs to appear only from the left at -3 to the right at 1. And we do have a closed circle here, an open circle here, and let's see what that looks like. I know it is going to be a parabola, and my parent parabola is going to open down and just shift 5 units north. That's what this is saying. So I'm going to go to positive 5, and I'm going to go over 1, down 1, and over 1, down 3, with that probable growth that we have, the single growth rate of just like a -1 out here. All right, so let's see what that looks like in terms of a parabola. All right, we've got our parabola graphed, and this parabola is only allowed to exist from -3, closed circle, to positive 1. So -3 closed circle, luckily we can see that happening right here. It lands exactly right on the money of our grid line. So we can just erase everything to the left of that and just pop a closed circle there. And then it stops with an open circle at positive 1. So positive 1, thankfully, we're right on the money there as well. So I'm going to erase that little guy and all of this stuff to the right, and then go ahead and put my open circle on positive 1, 4. Okay, so that was pretty easy. All right, let's move on to the next one. Okay, so this one's a little bit different. We have that f of x equals 2 when x equals 1. That's it. So that means basically I have an ordered pair of 1, 2 with a closed circle because it actually does equal. We don't have an inequality here. So we would just go from over 1 up 2 and pop ourselves a closed circle, and that is it. That's all there is for that last or that third piece of our piecewise function. So now we're ready to move on to our fourth function here, where our domain is x is greater than 1. So it's going to start here and move to the right from there. And we have an absolute value function here. And as we know, x lies. So we're going to get a vertex of 3. Y tells the truth, so we have a -3. So our vertex of our absolute value point, the point on the absolute value, is at 3, -3. So let's plot that at 3, -3. Now, what exactly do we know about this absolute value function here? We know that it is a positive growth because it has a positive value out here. There's no negative, and it's an invisible 1. So it has that normal growth with a slope of 1, and it's going to open upwards. Okay, so if it's got a normal slope of 1 and 1, we know we can go up over 1, up over 1, up over 1, and then that's the vertex, and it's going to go up over 1, up over 1, up over 1 in this direction as well. Okay, so let's get that graphed and let's see what we have to erase. Alrighty, so this is what our absolute value function looks like, and we do need to go back and make sure we're handling our domain correctly. All right, so let's take a look. X is greater than 1. So we know we're going to have an open circle where x equals 1. So let's erase everything from the left up to 1 right here, and it does need to be an open circle. So let's put an open circle right here, which makes sense because in order to be a function, we've got to look like that. And there you have it, folks. That is our piecewise function. And let's kind of clean it up just a little bit. Beautiful. Looks awesome.